Let's continue further and talk about this question. What does the question say? Prove that sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse 77 upon 36. Now, what should we do in this one? So, can we add two sine inverses? No, we don't have any result related to addition of two sine inverses in the NCERT, right? Although people studying for the JEE examination would realize that sine inverse can be added using some ideas over there, right? Sine inverse x plus sine inverse y is equal to sine inverse x under root of 1 minus y square plus y under root of x minus 1 minus x square, where x square plus y square should be less than 1, right? That should be the case. And what about this one? So for this question, what we'll do is, we can convert this in terms of tan inverse and this in terms of tan inverse, and we know a result to add to tan inverse, that is tan inverse x plus tan inverse y. What is the result for that? Let us write the result properly. Tan inverse x plus tan inverse y is equal to tan inverse x plus y over 1 minus xy. The condition that should be followed is x greater than 0, y greater than 0 and xy should be less than 1. This is the condition that is important for us, right? X greater than 0, y greater than 0 and xy, the product should be less than 1. Okay, since we want to use that formula, let's try to convert this and this in terms of tan inverse first. Okay, let sine inverse 8 by 17 is equal to theta and sine inverse 3 by 5 is equal to some other angle phi. And now we'll apply similar steps, because this is also sine inverse, this is also sine inverse. We are supposed to convert them in terms of tan inverse. This gives me sine theta is equal to 8 by 70. This gives me sine phi is equal to 3 by 5. Okay, let's draw a triangle. Yes, you can draw a triangle and get the value of tan theta very easily from here. Or you could use analytical method, that is, first find the value of cos theta. 1 minus 8 by 17 whole square and under root. Okay, what does this give us? Please observe, 17, 8 and another one which is 15 are Pythagorean triplets. How do we get that? This 17 square which is gone over here, 17 square is 289 minus 64, 289 minus 64 is 225. Numerator you will have a 225. Denominator you will have a 17 square. What is that? 15 upon 17. This gives me cos theta is 15 upon 17. What about this? This gives me cos phi is equal to under root of 1 minus 3 by 5 whole square, which is pretty simple. This is 4 by 5. And once we have found cos theta, sin theta, you can find tan theta. Tan theta is equal to this upon this, which is 8 upon 15, giving me theta is equal to tan inverse of 8 by 15. This is the value of theta, right? What about this one? Therefore, tan phi is 3 upon 4, that is sin phi upon cos phi. And this gives me phi is equal to tan inverse 3 by 4. Once you have found the values of theta and phi, again, yes, because you started with theta and phi, right? And you found that value again. So, therefore, the LHS is theta plus phi, which is actually equal to what? In the LHS, you have theta plus phi, which is equal to tan inverse 8 by 50 plus tan inverse 3 by 4. This is what you have, tan inverse 8 by 50 plus tan inverse 3 by 4. And if you observe, this is positive product. The product, as you can clearly see, is 24 upon 60, which is less than 1. The product is less than 1. So using this identity over here, what do we get? This can be converted into tan inverse sum, that is x plus y over 1 minus xy. This is what you are supposed to do, right? Tan inverse x plus y over 1 minus xy. Let's take the LCM. Let's multiply with 15 into 4, 60. Let's multiply by 60 in the numerator and 60 in the denominator. What do you get? This is tan inverse. 60 upon 15 is 4. 8 times 4 is 32. Plus 60 upon 4 is 15. 15 times 3 is 45. Okay, 60 times 1 is 60 minus 60 in the denominator, and this is 8 times 3, which is 24. What does that give us further? That gives us tan inverse. This becomes 77 over 36. Is it? Yes. And what do we want? We wanted the exact same thing. Yes, we wanted the exact same thing. This is equal to the RHS and that is the complete proof of this question. That's proof, yes, complete proof. Simple, yes. The important thing was to realize that we don't know the sum of these, but we know a result in terms of tan inverse, addition of 2 tan inverse, that is tan inverse x plus tan inverse y. We know that result and we want to apply that result. So let's convert this in terms of tan inverse, let's convert this in terms of tan inverse, and if you can guess that properly, you can approach the question in a very simple manner. You will convert in terms of tan inverse and then use this result very easily, right? So this question in itself is a combination of 3 simpler questions: interconversion, and then addition of this formula. 3 simple questions have been clubbed together to make this question over here, right? That is all for this question in this set.